Is all twisted. Hey guys. Oh, okay. This isn't the right size anymore. That's what happens when you clean it, I guess. Or maybe my head shrunk. Let me turn down that music. Holy. There. Hello. Good night. Or, well, good evening, actually. How are you all doing? It's 21:04, nice and early. Yeah, music's a bit loud. Yeah, it should be turned down now. Why is my headphone not fitting anymore? Is there still music? Oh wait, my microphone was actually pushed away. You should share that playlist with us. It's all from... now I forgot its name. Damn. Approaching Nirvana should be. Right. Let me check music. OBS. Music. Yes. It's Approaching Nirvana. And then the Coming Home album. The Horizons album. The Isolated Frequencies album. The Lapse in Time album. And the Resurgence album. And it's all of those. Double ducking? What? Is the audio not okay? We Lazy Link. No, just search for him on YouTube. He makes nice music. Now I feel the music's a bit soft, but you guys can, determine that better than I can. Yeah, exactly. There, turn it up a little bit. The volume of the mic is a bit soft and... Okay, let's turn the microphone up a little bit. There. In theory, should have more gain now. There. Oh, well, now I overloaded the microphone. Okay, a little bit back. There. That should be fine. Cool. Well, we're streaming in 32 megabits again. Seems to be going fine. Oh, I didn't start the recording again. Okay. Well, now I'm overloading the microphone again. There. Okay. Recording is going to... I did change some settings, so let's check. Yeah, video card's doing fine. Cool. Cool. Okay. So, first things first. Victor Moltanen, I hope you're still here, because you actually donated before the stream. That's awesome. If you want to do that, thank you very much. And thank you for the $5. Let me know later on if you have a question or something, or, you know, otherwise, thank you anyway. Good. So, I overloaded the microphone again. Let's, okay, I need to lean back a little bit. Relax. I was just going to say, Philip asked on the Discord, okay, the microphone's too loud. There. Put your lights in the background and go loco. And DJS just donated too. Holy shit. Let me first do what Philip said, and then I'll read the other one. So, I have profiles on my lights, which I run through Home Assistant, like here in the office. And it's currently on the medium random effect I made. All the donations are coming in. Hold on, let me put everything to my effect that I call Totally Loco, which is this one. So, we're going to do this for now. DGS says, "Hi Quinn, hope you are well. Got my genuine little fuses delivered today from CPC here in the UK. Thanks again for the tip." Yeah, I deliver all the boards with the highest quality fuses. I could get cheap Chinese knockoffs or whatever. Well, Little Fuse is a Chinese company. But I'd rather deliver good fuses and that I know they're good and they're actually going to do what they say they do. Because if you get generic ones, well, we've actually seen that in a few live streams, they might not do what you expect. Maybe you can run a 100 amp through a 20 amp fuse. That shouldn't be the case, but yeah. So, sure, no problem there, DGS. And Matteo Koning says, "It's not much, but I wanted to thank you for your help during the previous stream and on Discord. Greetings from the Netherlands." Thank you very much. That's very much appreciated. And yeah, we're always ready to help on stream or in the Discord, etc. We love seeing completed LED projects, so we try to help people along. Oh, Victor is here. Nice. If you had any question or comment with that, just let us know. And if not, thank you all the same. Can you do that all stream long? I don't know. I think it... Well, I was going to say it's going to use up more bitrate. But then again, I have more bitrate going up. Doesn't mean you're getting more bitrate from YouTube, though. But I don't know. It's a bit much, isn't it? Will there be any secrets today? That's a good question. Maybe have some little bit. I don't know. I didn't check that yet, Emil. I was a bit busy. I'm gonna go down from Totally Loco to the fast random effect, because Totally Loco is a bit loco for me. Okay, so this is the fast random effect, and well, I just checked it. I put it in Discord, right? How often does the fast random effect change? The fast changes every 10 seconds, and the medium, I have it on normally, changes every 30 seconds. So, and the Totally Loco we just watched is every 250 milliseconds. Yeah, it is loco, absolutely. Okay, to make Philip happy, I'll compromise. I'll put it on a very insane random effect. I believe that's every second. Totally Loco is just too much, man. There. Oh, this is kind of much too. No, I don't like it changing that fast. I'll put it on fast. Oh. That basically picks a random color every 10 seconds and then takes 10 seconds to change to it or transition to it. And because it's analog, it doesn't just have 255 steps like we're used to from our generic WS2812B, but it has thousands of steps it can do, so it can actually do it very smoothly over the whole curve. Well, that said, a friend of mine came to me recently and said, "Hey, I know you like weird cokes on your stream, right?" And I'm like, yeah. And she was like, "Hey, have you ever seen Coca-Cola Zero Sugar, Rosalia? It's a limited flavor from, I think, Japan. Oh, well, no, this has readable letters. She had some other stuff there that wasn't readable at all. It was all Japanese characters. But yeah, this is Coca-Cola Zero Movement. And then the Rosalia, I don't know how to say that. I don't know. It's odd. But we're gonna try that out today. Never seen those before. But yeah, she likes getting weird ass cans. She's like, "Here, have some too." And I've got some vanilla. I'll start with the vanilla, and then later we'll drink the special one. And no need to ultra that up. It's already special by itself. So, okay. So how about we start the stream with a little bit different than the main topic, and that is checking out the analog board from the last stream. Sounds like you have to loco them. What? But checking out the analog board from the last stream, because I made some changes to it. This is still the one we... I know. This is still the one we soldered together last time. Look, can I zoom in more? But the only thing I've been changing is the resistors on there. Right? So I changed a lot of those resistors, etc. Because as I mentioned in the last stream, I still needed to play with those to find the right values. And, well, I think I've gotten pretty close. It's not perfect yet, but it's getting there. Of course, I didn't prepare an analog strip. Let me get one. Hold on. Would this be one? No. That's the wrong street. This could be one. Yeah, that'll do. No, it has the funky connector. I don't like the funky connector. Well, I stripped the wires. It's fine. Okay. So here is the here's some analog RGBW. Well, you can see it has this funky connector. I don't know why, but we'll look it up anyway. I'm missing my music. Did you happen to test test warm white cob LED strips from BTF? I only get 2.5 amps with a single injection, 12 volt. Oh, that's a good question there, Matteo. It really depends on which one, and if we're talking analog or digital. And, yeah, a few of those things. So, wait, I'm getting distracted. No. Okay, let's hook this up. This goes to the output. Screwdriver. So this is still the board from last time. I've just made some resistor changes. And I have been scoping it. I'm not quite done yet. When I have the real values, I'll build another board as a second pixel to hop over, and then make some final improvements, and then I might actually release this thing. Still need to do final cost calculations and things like that too, but Right, so board is done. Let's get a dig quad here, and let's get some 24 volt power, because this LED strip should also be 24 volt. Yep, this board does 24 volt, and the dig quad does 24 volt. Everything does 24 volt. Should be a pretty easy, quick test. And we're gonna need this dig quad later anyway, so. Yeah, it's a bit hard to judge there, Matteo. But we could check it out on the Discord maybe. Okay, so we hook up my little board here as if it was a little single pixel, and then we have the cob LED strip here, right? And let's power this up. I think nothing's going to explode. Okay, power supply is booting. We're going to look at RS485 today, yep. So, VSET 24. Let's set it to 4 amps. Positive, positive, positive. Yeah, should be good. Nothing's happening. Why not? Because I didn't hook up this power supply, I hooked up another one. Okay. It's always the most scary thing when you turn on your power supply and nothing happens. Best case, like now, I just hooked up the wrong power supply. Okay, let's plug it in. There. Ah, now we got a light here. But we don't have a light here. Why not? Uh-oh. Did I break something? Okay, let's turn it off. This was supposed to be a very quick test. Did I blow that fuse? Hold on. Sometimes these fuses are in so good, you need a tool. Let's get that one out and this one out. No, that fuse is good. I had wondered about this connection though. Well, that should be good. Huh, did I wreck it and not remember? It's possible. It's always possible. This looks good. Is that my 5-volt power supply? Oh! Can you... Really? Oh no. Okay, this shouldn't do that. I think I know what's going on. I got the wrong power supply again. I have two Meanwell UHP 500s on my desk, and one is 5-volt. Well, actually, let's show you, because you're never gonna believe me. Let's turn the multimeter on. Might need it later anyway. Start. The device is not connected. The device is not connected. What? What do you mean? Okay. It suddenly stopped working? What? Why? Oh, I know why. I think I might have destroyed this network cable when I was a bit ragey, and I was like, more stuff needs to fit on my desk, and I pushed it really hard. And is it okay? It's still too loud. Okay, I'll turn the music down a little bit. There. Right. So multimeter is probably a no today because I wrecked the Ethernet cable. Let me check. Yeah, that's pretty badly kinked. Okay, let me check if I can get it online, and if not, that's no multimeter today. should do it. I need a bigger desk. Okay, let's restart the software. Yes. Still saying not connected. But is that true? Ping ping. No, that is not true. It is online. Connect. Alive. Ah, there we go. Finally. Okay. So now we have a multimeter. So what I did, I hooked up a power supply, one of my power supplies on my desk. I got the wrong one. Then I hooked up another power supply. And, well, as I was saying, I got the wrong one again. Because I have one a UHP 500s on my desk. And this one is, well, if I do it correctly, 5 volt. Right? So the board's getting 5 volt. This is also getting 5 volt. Well, it's actually a thing I wanted to test. This board is not 5 volt compatible. It wasn't designed to be 5 volt compatible, so, you know. But now we tested it, that it isn't. Okay, let's get a different power cord again. Plug that in. And then I need to move some screws here. Oh man. Everything's in the way. Okay. I believe there are 5 volt analog strips, but they're not very much spread, I think. I generally use 12 volt or 24 volt, because with analog it matters a lot less than with digital. So, yeah, I wouldn't know why you want to use 5 volt analog. So, yeah. So now there's 24 volt on there, in theory. If I hooked it up correctly, no light again. What? Oh, why is it still the wrong power supply? This isn't my day. Where is this power cord? Oh, it's in the mess. Okay. Okay, one last try. There, we have power and we have LEDs. Finally. Jeez. So now we have 24 volt on here. Yes, if I did my connections correctly, but yeah, 24 volt on here. Yep. Okay. Yeah, I know, Philip, I know. So now I just need to look up the IP for this controller, and that is 108. There. Okay, so the idea is just I wanted to show you that it's now actually doing what it should. So we can set it to red, we can set it to blue, and it nicely transitions because I have a transition set of 2 seconds in WLED. And then we can set it to green, and we can actually set it to white. Isn't that amazing? So this one is sending pixel data to this little board. This board is extracting that pixel data and making it into PWM for analog dumb LED strips. And now we're PWMing this LED strip. And so you can use dumb LED strip as giant pixels, basically, right? Let me take an effect here, a color loop. And let me turn that down a little bit. There. Actually, let me change my camera a little bit. Because then you can see it's nicely transitioning. There's still some things I want to optimize on here. It's not perfectly smooth yet. For instance, red seems less powerful than the other colors for some reason. Might need a slightly different resistor value for red versus the other ones. But other than that, it's doing what it should. Well, the effect looks kind of stupid because there's only one pixel, but yeah. But at least versus what we had before, this is working a whole lot better. So we can actually dim down green all the way to 0. Let's change it to blue and all the way back to full power. Or we can change it to white and then all the way to 0 again. And all the way up. And that's working nicely, and there's a nice dimming curve and fade and things like that. So, yeah. So chained 3 of these analogs doing traffic light will work. Yeah, sure. Absolutely. I've seen analog controllers with 5 volt to 48 volt support, so there must be a reason. What do you mean there, CJ? You mean my other prototypes? Well, this only has 4 channels, not 5. And you might want to consider a true analog controller board, which I'm also making. Those should be done hopefully soon, but at some point. This is more of a in-between. If you want, for instance, 50 analog strips, well then using an analog controller, you're quickly going to run out of channels, especially if you want to do RGBW, because you need 4 channels then. And then getting, a bunch of these boards is going to be a lot cheaper and a lot easier to manage, having them as pixels and still being able to control each individually. Or you could even do effects over all of them, etc., etc. Oh. So that's basically the idea. But yeah, I just wanted to show that it's now actually doing what it's supposed to. Instead of last time still not quite. Right? Well, it fades nicely. Yeah, my controllers, including this one, aren't targeted at 5 volt. For the digital side, yes, but not for the analog side. Right. Speaking of the digital side, the subject of today. Now I need to move it back to the 5 volt supply again. One moment, please. Pull that out. Put this one in. There. 15 minutes late, but here we go. Right, so we currently have a dig quad here, which is being fed 5 volt, and we just have this little pigtail on there, and we can connect an LED strip. Let's do that. Let's turn it on, see what happens. Right, oh, it turns on, but I only have 1 pixel configured, so let's change that real quick. 300. Save. There, and now we need to fix this. That's also not correct. Is it GRB? Yes. So now we can go to red. We can go to blue. And we can go to green. Let's see what Josh says here. Afternoon from Florida. Just got a box of Dig-to-Go's and Unos from Dr. Z's. Both Unos came with the ESP wedged into the headers. The blank pin sleeve doesn't fit. How important is that sleeve? I'm not sure what you mean with ESP wedged into the headers. If it's just socketed on the board, that's correct. And that little blank sleeve that's there, It can provide some protection during transportation, but otherwise than that, it's not really needed. It's more of a cosmetic thing. There's nothing that's going to short or anything like that if you don't have it on there. I generally don't have it on there. Actually, I don't think, this one doesn't have it on there either. So, yeah, exactly like Philip is saying too. Right, so we have a Dig Quad here. It's a prototype board, doesn't matter. And it's controlling this LED strip, and we can do cool effects like, BPM. Let's set it to the default color, or something with a lot of colors. Color waves. Or fireworks starburst. Right? So we can do cool effects on that, and, well, that works fine. But now we want to do this very far away. And as we've all probably learned with digital LED strip, if the further you or the longer you make the data cable, the worse the signal gets. And with the level shifter stages and resistors and things like that that are on the dig boards, you can generally get away with about 10 meters or 32 feet without any problems. But if you really want to go much longer than that, that is certainly going to be an issue. Now, if you have 5-volt strip, you don't want to go that far anyway. But nowadays, with 24-volt strip, you might want to. Because, 24-volt, you can easily transport that 10, 20 meters away from your controller. But then your data signal isn't going to make it. Before, we had... Before we had data booster boards. I don't have one here. Well, I should have some, but... We had data booster boards, and those were introduced for multiple reasons. If you want to do power injection with just screwing stuff down and not soldering or Wagos or things like that, they could be used for that. If you wanted to boost the data signal behind an LED strip, because the data signal coming out of an LED strip with integrated LED chips just isn't great, and you, for instance, needed to gap 3 or 5 meters, you could use it for that. Or if you needed to adjust the data signal for the cable you were running it on, either 2-wire plus a data wire or 3-wire cable, the data booster introduced a resistable or a resistor switcher, and you could set it to 33R mode or 249R mode. But in the end, the data booster wasn't really meant to get you more distance, because if you have a distance problem, it's probably because you're encountering interference from something AC, something high voltage, a compressor in a fridge, a microwave, or something else corrupting your data signal on the cable. Because in the Dig Octa livestream, we saw that here on my desk, I could get 60 meters or 200 feet of data signal travel, no problem. But in real life, it's not that easy, because any kind of interference that will try and influence the signal, well, the signal we're sending, the LED data signal itself, it just isn't very robust. It's a single wire signal, and anything exterior can easily influence it, basically. And well, I often get into discussions with people like, hey, but what about Ethernet cable? I can run that for 100 meters, and it carries a much complexer signal. And so if I run my data signal over Ethernet, that's going to be a lot better, right? Well, to start off, if you like theory, there is now an article that's called Why Ethernet Cable, Cat5e, Cat6, etc., isn't suitable for LEDs. So I'm going to plug that article here. That's, if you want to read stuff. But basically, the type of signal that we have for our LED data is a single-ended, single-wire, or one-wire signal. I've done the best I can to make it a good signal so that it survives like 10 or 20 meters or whatever. But as I said, if there's interference, there's basically not much you can do. So then people, but how does the Ethernet work then? Well, the Ethernet, or the network signal you're running on that, is a different type of signal. It uses 2 wires, and it's called a differential signal instead of a single-ended signal. And what that means, it uses 2 wires, and it basically makes 2 extremes, so that if there's a 0 or a 1, it's not a 3.3 or 5 volt difference. It's a -7 and a +7, so a 14 volt difference. So then it is much less susceptible to outside interference. Also, because if one of those gets affected but the other one doesn't, the signal doesn't degrade as easily, basically. So what I built is, and this isn't unique, other LED controllers and stuff on the market also do this type of thing, is but they have it integrated into controller, and it's always 4 channels and things like that. But what if you have 1 channel? And this is just a first prototype. I plan on making different type of boards, so 2 channels, 4 channels, maybe a hat for on the DIG Uno and DIG Octa, or a version of the or DIG Quad and a version of the DIG Octa. But that's all future talk. First, we need to validate this will actually work. So I created 2 boards. This is a Quinled diff sender 1, because it has 1 channel, and it has Ethernet out, as you can see here, right? And then we have a Quinled diff receiver 1, which takes Ethernet in. It then takes power in. It has a fuse, it has a local capacitor and things like that, and it has a level shifter on there, and then it has a single LED output. Okay, so the idea is we hook this up in between, and then we transform our single-ended data signal into a differential signal. Then it travels over Ethernet, which is made for differential signaling. That's why they're always in a 2-pair winding. And then it comes out the other side. We transform it back to a normal signal, and then we feed our LED strip. Yeah, exactly, Philip. It's a much more robust form of signal versus what, comes out of the controllers normally, because that's what the LEDs need. So the first test we're going to do is we're going to disconnect this, and we're going to connect my little prototype board here, like so. There's a little LED on there, but it's nothing special. It doesn't show you anything. And now we'll take this Ethernet cable. This is a very thin one, but it's nice to use on my desk. But we'll try a lot more later, because this is basically what we're going to do today. We're going to see how far it can go. And this is a 10-meter cable, which would already be somewhat challenging for a normal data signal. Now, there's already one bug on this board, and I'm not sure how I'm going to fix it yet. And that is, if you use the little feed screw here, because I made it a feature that you can use the feed screw, you can see over here, that's no problem. That fits in just fine, right? Over here, though, this screw kind of sticks up a little bit. And if I use this Ethernet cable, that's fine. Although it's not even really touching. But if you use an Ethernet cable with a thicker tula, I don't know how you call that, connector, whatever, it could actually be somewhat crooked. So maybe we'll test that later too, if that's a problem or not. Right, so now we just have this. We have power, 5 volt or 12 volt. This board only takes 5 volt or 12 volt. For this variant, I'm making another variant which will do higher voltages if needed. But one of the nice things is this board and the other side don't need to be running the same voltage. But we'll get to that later. So we got power, data, and ground coming in. We see that the LEDs turned on, and we've got Ethernet RJ45 coming out. Okay. Then we have 10 meter of cable. Yeah. And we there we have Ethernet coming in, and I use these nice yellow Ethernet sockets so that RS485, you can't see, RS485, not Ethernet, RS485, right? And well, we'll hook this up to the LED strip on this side, but of course it only transfers data. There's no power being transferred. Yeah, maybe, but these are the screws that come with those little feet, and I need to think of a way to hopefully make that compatible, or indeed recommend a different screw. But best case, it would just be compatible with the screws that come with those little feet, because you can buy a bag of 50 of those feet for like, I don't know, $3-4. I need this for steps. For steps? How far are your steps in between? This is really if you need a long distance. All right, so let's look at my variable power supply here. And let's see, VCC and ground. No tape? What do you need tape for? What? I'm so confused. We've been talking about it on your Discord. Ah, yeah, well, you could actually use the analog board I showed earlier for your steps. This one, this is for if you need really long distances. If you need a short distance, you should get the data booster board. Power wires are wrong. Oh, you're right. Thanks, Philip. Well, there's a fuse on there. And some rudimentary reverse polarity protection too, but that would have been interesting. Oh, man. I'm really not paying attention today. Sorry about that. 120 kilometers. Yeah, well, that's a bit much. This should in theory do at least 100 meters, but we're going to test it today because I have a bunch of cable here and I have no clue if that's going to work. So let's figure out first if this works, right? So now we have power here. Let's set that to 5 volt and 5 amp. Because this is, that 5 volt strip we used earlier. This is now correct. We have a 5 amp fuse in there because it's an edge injection, so 5 amp should be fine. Then we have a capacitor here. Power. It immediately works. Stupid me took away the chance of smoke. Yeah, that's probably true. So now we have this data signal coming from this DIG quad. It goes into this little board here. It goes through this 10 meters of Ethernet or unshielded twisted pair cable. And then it comes out the other side. We transform it back. We feed it power because... Oh, wait. I didn't screw it down. What? Why not? Oh, wait. The clamp wasn't lowered. That's what you get for using high-quality screw terminals. There. Almost had smoke anyway, Philip. Did I screw it down correctly on the other side? Yeah. How many meters can you do tonight? I don't actually know. We're going to try a bunch of cable first, and then I actually have one of these, one of these boxes, and it's pretty heavy still, and this was 305 meters. I'm betting there's at least 200 meters still in there. But we're going to take a look at that last. We're actually going to have to crimp connectors on that. So yeah, this is the idea. DIG quad, data signal, put it into the board, go through lots of, long length of network cable, transform it back, and of course you need a fuse here, and as I said, I'm planning on making 2-port and 4-port variants too, and then I'll have power distribution, fusing, and things like that on there, of course. And then, it goes into your LED strip, and it functions like normal, like it's literally right beside you, except it's very far away. Let's go to Paletti. There. Right? It just functions like it's right there, but it's going through a lot of cable. Now, one of the fun things we can do is the power you have on this side, the voltage, doesn't have to be the voltage you have on this side, because this side is getting its own power, right? So we can actually disconnect this 5 volt strip, take a 24 volt strip. This is one of those COP strips. Let me check if it's really 24 volt. Yes, 24 volt. There. It's still on 5 volts, so it's not doing anything, but let's set the power supply to 24. And there. Oh wow, it's too bright. Whoa. And there you go. Now we have a 24 volt strip working on this board instead of... while this side is still 5 volt, this is now 24 volt. Works perfectly. Oh, well, synchronized isn't the same as actually extending the data cable there. Siegfried. And also synchronize does the same effect, but it doesn't continue the effect, for instance. No, there's no shared ground currently. There is an option on the board to actually solder a shared ground, but it's currently unsoldered because I didn't need it. But there's no shared ground between these two. If it just works immediately, it's not exciting to watch. yeah, I get that. How far will it go on untwisted cable? Well, it's not made for that. I don't know. But let's start experimenting, because the experiment today is how far can we extend this, right? So let's start. I have a few of these little blocks here, which is, you know, the best data connection you can have. These little female to female blocks, but we're going to use them anyway. So let's extend it with another 10 meters. So we're going to put this in the block there. We're going to put this in the block there. This is another 10 meters. So now we're at 20 meters. Yeah, that works fine. Let me slow that effect down a little bit. There. Okay. This is, I don't know how long, but it's pretty good amount of cable. Do you think it actually says? This is Cat 6. It doesn't actually say how long it is. I don't know how long it is. Let's get another one of those blocks. Yeah, so, okay. Let's, you know, add this in between. Let's put it there. And let's see what it does. Okay. Well, still working. Isn't it marked on the plug? That's a good one. 20 meters. 20 meters. That's a good one, Philip. Thanks. 20 meters. So now we're at 40 meters in total. Okay. Okay, now I have to get a special one. This is one I made a while ago. So, this is Cat 7. So this is actually PIMF cable. So it's kind of cheating, because this is the ideal cable. But let me check how long this is, because the meter should be on here. Probably around 30, yeah. Well, let me check. It should be on here where you're at the cable. Or somewhere, right? Shouldn't it? Let me see if I can find meter. Oh, 0.24. Okay, I need to find the label here real quick. Hold on. Okay. This is 0.32, so 32 meters on this side. So let's find it on the other side. This is 2 meters. So this is 30 meters of Cat 7. Okay. So let's let me try and show you the best I can. We might see a little bit of my hanging solution there. But yeah. So let's disconnect this. And this was already 40 meters, I believe. Let's connect this in there. There. Okay. And now we need another cable. We're going to go for broke here. Oh, this doesn't say the length again. It says... Oh, 15 meters. 15 meters. So this was... we had 40. We added 30. And this is another 15. Okay. Okay, well, this didn't go in easily, but it went in. Okay, it's still working. 85. Is that correct? 40 plus 30, 70. Yeah, 85. Yeah, okay. Well, I have one cable left. What? How long is that? 10 meters. Aw, we're just shy of 100. But we'll crimp some connectors on that Ethernet, on that whole box later, and then see if that works. So now we extend it again. Okay. There. Still works. Strip starts to lag? No, it doesn't. It shouldn't. I mean, it's either getting there or it isn't. I can turn up the speed if you want. I can turn up the brightness. Wow. I just, made the effect less fast because it was going a bit fast. No, I believe we're at 95. Right? And there's some Cat 5e in there, some Cat 6, some Cat 6a, and Cat 7. Yeah, I know, but... Because this is also PIMF, so pair in metal foil. Yeah, it'll start to flicker or do other weird stuff. It shouldn't slow down. I don't think that's actually possible. So yeah, we're still running a 5-volt dig quad. 5 volt to this little board. 24 volt to this board. And then 24 volt to the strip. But we can also make this a 5 volt strip. Seems the prototype works. Right, but coiled up wire on the desk would have worked? Maybe. But it still verifies that... whoa, okay. Maybe it's a bit fickle here with metal connectors. It still verifies that the other signal at least also works. Yeah. So... Well, maybe. I don't know yet, Mr. Blue. But the next thing we're going to do... Let's turn this off real quick, because I don't want to short-circuit it on these metal connectors there. Let's move this out of the way a little bit. There. Let's get that box of cable open. See how much is actually still in there. Crimp a connector on it, or crimp connectors on it. And then let's see if it'll do that. Because I have no idea. Okay. So... we have this box here. And it still has a lot of cable in there. You see that? I mean, it's still basically at the top of the box. Although, of course, it comes from the inside loop. But we'll have to check what marking the cable is. Cat 5e. Okay. This one here says 165 meters. Please remember that for me. And now I need to find the other side. Would that be tied down somewhere? Oh, no. Don't think so. Where would the other side be? Yeah. Hold on. I really don't want to rip it out of the box because I'll never get it back in there. Where would the other side be? Nope. Not on this side. Yeah, maybe I should have prepared this better. I don't know. Oh, I found it. I found it. Okay, the other side says 001. Okay, so we have 001 and 165. Okay, so let me get this out of the box a little bit and some of this, because then I can just put the box on the ground. Okay. There. Well, actually, let's put some cable on there so it doesn't slide off of the desk the whole time. Well, this cable should do. Okay. Right, now we have these two ends, and, we'll have to put connectors on there. But it's actually, we're doing a surprise queen boxed. Yeah, we can do 260 meters in total. If that's not enough, I don't know. If it does that, I'm okay with that. So we got a surprise queen box because we have this little package here, and it should, not 100% sure, have some new Ethernet plugs and crimping gear in there. Because I saw it come by and I was like, I need that. So we're going to check it out. Is my address on there? Hope not. So this is a surprise queen box, but I'll probably also show them in a real queen box soon. So we should have a tool in here, which is it's a professional tools, right? So that can't go wrong. And this is a new crimper, because what it does, or at least what I liked about it, okay, is that you can put plugs in here which the wires go through. I do have a crimper, but this is a new one. I have my normal crimping kit right here. I have a box that is my normal UTP crimping kit, right? No worries there. And we're also going to use the tester in there. So what it does, it actually cuts off the excess wires when crimping it. So we're gonna try that today. Oh, you get some extra knives with it too. Okay. So let's see what else is in here. We have some plugs, but I ordered different types for Cat 5e, Cat 6, Cat 7. Yeah, so I've never used pass-through plugs before. So we're going to try that today, and you're going to be witness. So, okay, these are some metal plugs. These are most likely for my Cat 7 cable, because they're a larger diameter wire, and you also have stranded and solid cable, so you need different kind of plugs for that. Or you can get universal. I got some thingies to go around it. So these are different then, maybe? I'll need to look at the product number. No, these are exactly the same. Okay. Oh, and these might also be... Oh, okay. So these are, again, for wire ends. Okay. Sure. So, let's get... well, we were doing yellow, right? So let's get some yellow. I don't have links for these right now, but I will have in the Queen box when I eventually... is a pinky cutter tool. Well, you'd have to have very small pinkies to get it in there. Strip, lock, cut, what? Okay. Anyway, well, since these are all the same, except for these. Oh wait, no, it's also the same. It's just not labeled. Oh no. How do I know which ones are which? Well, we're not going to figure that out on the stream today, so we're just going to take this back and assume it's the right one. Yeah, so I haven't tried the pass-through yet, and we're doing that right now on stream for the first time, right? Yeah, so these are the pass-through type. Okay, so let's see if this new tool. I like that it has the colors on there because I always have to look them up, and you know I don't do it often enough. You can cut it and strip it. So this cuts it and this strips it. Okay, let's try that. Let's try cutting it. Okay, sure. That cut it pretty good. Oh, those are, yeah, these are staggered. So they're for Cat 6. Let's see if the other ones are different. Are these not staggered? Oh, yeah, they're not. I know I got them, I got all the different types, I believe. So let's check it real quick. Yeah, these are the non-staggered variants. I'll show you a close-up real quick. So what he said is we have two different variants here. Let me focus that. And I bought three different variants. Cat 7, but then those are the ones with the metal on there, because Cat 7, you know, has metal foil and stuff like that. Then we have the Cat 6 here, which is staggered, probably. And or I likely agree with that conclusion. And then we have the non-staggered version, and that's for Cat 5. So that's this one. This one likely also takes slightly larger diameter, it seems. Yeah, this is all unshielded cable, it doesn't matter. And in my application, I'm also not using the shield, so that's not going to matter. So let's put these staggered ones away. Thanks for noticing that. You have a keen eye there. So now we have two of the unstaggered ones, right? Oh, well, I like that they have the colors on there, but I never know which way the plug should point. And we're going to use the B variant. But I believe the plug should point away. So the little springy clip should point down. What do you guys think? That would also line it up with the tool, right? Uh-oh. Get the plug out there. I guess they lined it up. Yeah, well, it's Chinese. You don't know. It's still going to break. What is going to break? Clip down. Yes. Okay. Let me see if I can get you some more light. Maybe like that? Yeah, okay. Right, so we used the cutting part already. Let's use the stripping part. Let's see if we didn't cut any wires. Huh. Doesn't seem so. Nice. Does it send at megahertz? No, it's an 800 kilohertz signal. So, like this, we need to turn it around. Oh, you can do that with unshielded cable too there, Emil Bart. Or at least you should be able to. So I did my normal thing and strip it as far as I thought we needed it. But now we shouldn't need to do that. So let's strip it a bit further, just to make it easier to work on. Get the colors again. So orangey. And I've done this hundreds of times. I'm out of recent practice though, but you know. Okay. No, we need green. And then we need blue, blue, green, orange, orange. Interesting, Emil. Well, if you want to go all out, you should use Cat 6A or Cat 7. Cat 6A PIMF or Cat 7, which is always PIMF. Like the orange cable here. And that is pair in metal foil. That's the best shielding you're going to get. And then just connect shield to ground. Yeah, so we have... well, let's stick it through first. See if that works. Yeah. And... oh, wow. Okay, that's easy. Because now you can always push it in far enough. Before I always struggled, like... stripping it correctly, the length, and then having this punched down correctly and blah blah. So let's verify the colors. So we have brown, brown, white. Then we have green, and then we have blue, white. And then we have blue, and then we have green, white, and then we have orange, and yeah. So the theory, why not Cat 8? Quit almost back. I don't know about the cable composition of Cat 8. I believe it's just twisted differently. My whole house is Cat 7, so... and I run 30-meter long 10 gigabit links, which work fine. But so in theory, I can now just put it in there. And crimp it down. And it should cut the wires to length automatically. Let's give it a good squeeze. Now, should it unlock? I don't know. How does this work? Oh, there's still wires here. Huh? Well, that didn't work great. How does it open? Interesting. Oh, okay, there's a lock and an unlock thingy. Oh, okay, the cables came off. Let's get this out. So this side looks fine. That looks correctly tensioned. And let's see if we see little bite marks. Yep. So you can, in theory, see these little bite marks on there. You know, seeing the little teeth go into the cable and come out the other side. So if you check here, you should see little teeth there. It's not perfect, but it's good enough, I think. These actually have 3 teeth. I'm used to having them having 2 teeth. And this is solid cable, because this is cable that should go into the wall. But yeah. Yeah, so James, Derek, I'm using 10 megabit transceivers on my testing boards. In theory, a 2 megabit could have worked. But I was worried it might be too slow for the type of signal we're using. So I went, you know, for the safe thing and used a 10 megabit transceiver for the RS485. So I still have to scope the signal. We're just doing preliminary testing, but so far that looks good. But yeah, it's an 800 kilohertz signal, and we should, in theory, have 10 megabits of bandwidth. Should be fine. Should be fine. Yeah, B is mostly used. Yeah. Right. So let's just do that again quickly. Yeah, I kind of like this because now the untwisted side or the untwisted length is always as short as possible. No, wait, yeah. It's always as short as possible because you're pushing it against the cable as far as it'll go. Instead of having a lot of overlength, I would sometimes have. And you know, it's twisted for a reason, so keeping that twist as long as possible is a good thing. So let's see here. We have orange, yeah, and then this is green, white, blue. Yeah, that looks correct. Can I now just, oh no, shove it in there? And in theory, it will stay in the right place. We'll have to see. So now I shoved it in there, so it goes really close to the plug. So let's verify that one last time. We have brown, brown, white, green. Nope, that's wrong. Oh, the boot, yeah. I forgot it on both sides. Let's do it on this side, you know, to try it. Okay. No, I got it, Philip, but it's too late for the other side. And I'm not going to string it 165 meters along. So let's try that again. I usually start from the round. I don't know why. Brown, brown, white, green, blue, white, blue, green, white, orange, orange, white. Yeah, okay. I kind of like this. Oh, it's not going in because it still has a... Oh, no. It screwed up the wiring. Why? Okay, so we need to move the boot up there because I think you need to crimp it in. Right? So the knife moves when you push the handle. Okay, let's push that in again. Yeah, now it went in correctly. I always like to push on the cable when I crimp it down. There, and it cut all the wires automatically. Let's get that out. Okay, yeah, cut it automatically. That's good. No wires left. And, oh, we need to put this one under that one. I generally don't like these boots, but I thought I'd buy some, see how these are. It's not coming out. Well, on one side it is. Yeah. I guess it's okay. Anyway, let's do a check. Teeth went in, it seems. Okay, let's get a cable tester there. I used to have a very fancy cable tester with like 8 remote nodes and things like that. And then it broke, and I never got a good one. And now I just have this cheapy one, which is fine. Well, there, let's see. That looks pretty good. 2 seems a little bit weaker for some reason. But that can be anything. Yeah. Should be good. It's 65 meters too long. Yeah, well, this just, you know, puts 9 volts on it or something like that. Now, just to give Philip a rest, you know, my other tool is an actual Knipex. So it's an actual brand tool, you know. So, don't worry. Still, you know, for people who just want to make some of these RS485 cables, well, I just made them with this tool. Seems fine. Tester can't handle Pee-wee. Yeah. Oh, you put Pee-wee on one of those testers? Let me get these little strands off my table here. Did it blow up, or... Jan? Did you kill it? Okay. Moment of truth. Let's, Oh, I don't have any couple blocks anymore. Okay, I need to take the last cable out. So that's minus 15 meters. No, but yeah. Oh, minus 10. I'm taking this one out. This one was 10 meters. So minus 10. I don't know where we were, what we were at. And then we're just going to add 165 Knipex flex. Yeah. Yes, it's dead. Okay. Let's take bets. 250 meter total. That's a very nice total. I have no idea if this is going to work or not. Zero idea. Do a poll. Okay, we'll do a poll. Let's create a poll. Poll. Will it work? Yes or no? Go. Yes, Savag, don't remind me either. Oh, wow, everyone's saying yes. 250 meters, the guaranteed working one with PXL net and transceivers. Well, this is just my own homebrew shit, so I don't know what they do. This is what I do. We're betting if all this cable mess that's still here on my desk, so this cable all is still in between there. Oh no, the bags are emptying on my desk. Oh no. Okay, let's put that away. And then we added the 165 meters of extra cable roll there. We're trying to bet if that's going to work or not. I hope it will. I have no idea. I actually have no idea. The stranded cable directly into there sucks, but you know. Well, I don't start from the brown side, but I count from the brown side for some reason. I don't know. Okay, let's end the poll in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. End poll. We had 52 votes, and 98% said it will work. You guys are very confident in me. And 1% said no. What? How does that work? 98% said yes. 1% said no. Then what did the other percent say? It must be a rounding error. Okay. Well, here goes. Let's turn on the dig quad first. Okay. The sending board is on. Okay. And now we need to apply power to this side. 24 volt, that's correct. Go. It's green. The color order is probably set wrong. I can lower the colors. Pride 2015. There we go. That looks right. 98% of you was right. It's 1.9% that they averaged it down. Yeah, I think so. Isn't good at the math. Rainbow. Yeah? Oh, wow. It's over. These 24 volt strips are so bright. Yeah? So let me turn that down again. There. More cable? I don't have more cable. I never win. It was you, wasn't it? You were that 1 to 2%. We don't know how much you were. I don't have more cable. I honestly didn't know if this was even going to work. I have some more Cat 7, I think. But I really don't want to crimp that. I don't know how many meters is on there either. Oh, and it's on a spool. I can't get to the end. Yeah. So this is a 10 megabit transceiver on both sides there, Jan. But the speed it runs at is the speed it runs at. So we're only sending an 800 kilohertz signal into it. But clearly that is surviving okay without a problem, right? Ask your neighbor has some cable. No. That could be ringing on there, but there are termination resistors in there. One thing I want to do is check the thermals. This uses one pair, yes. I did think about that Narmiak, but then again, you wouldn't use one Ethernet cable for multiple signals unless you had a multiple channel in sender and receiver board, right? So being able to choose which pair it goes on, it's limited usage. I am planning on something like that for one of the dig boards, but I don't know yet. Yeah, this has a 120 ohm termination resistor on both sides. Now let me check how warm the sender board is getting. Oh, well, that's not exciting. The sender board, why can't I see it? There. Okay, the sender board is getting about 42, 43 degrees. 43, yeah, that's fine. And the receiver board doesn't show up on the scope. Oh, there. The resistor shows up a little bit. And the resistor is that the resistor? Yeah. Is it? Yeah, it should be, yeah. The resistor is 32 degrees. Oh, I've actually seen it hotter, but probably because of all the cable in between there, the termination resistors are actually kind of running cooler because there's little cable between there instead of warmer. That makes sense. If you only use one pair, you could extend it 4 times. You mean loop it back and forth? Why would you do that? Yeah. Well, as I've said before, if it just works, it kind of is boring. No smoke. Out of curiosity, try removing the termination resistors and see if it still works. That is not possible. As in, they are 0402 and it's wedged in there, like over there. I'd have to melt half the board. A cursed 1 kilometer loop. No. No. No, and I can't reach this side either. It's right. No. But as far as I understand RS-485 and the data sheets and everything like that, you kind of need some termination resistors in there. So let's see what power usage is when I turn off this. Oh, right. It still has the LEDs on there. Yeah, so the receiver board basically uses no power whatsoever. That's good. Well, no, but there's, you know, pins there. So it's going to be really hard, and I kind of don't want to destroy this prototype because I want to do more testing with it. So, but the end version should have resistors on there anyway, so. What? You saw ADSL running over barbed wire fencing? Okay. So this was, how long was this? 165 plus 95 minus 10 is 85. I always tell myself I have to calculate everything on the stream. Yeah, 250 meters. Well, 250 meters ain't bad, man. Yeah, better have a good secret. I don't have a secret. Well, you got to see a preview of the Quinbox crimper. Is that a secret? I really hated ADSL. I know it made sense in some ways, but in other ways it just sucked. So, as I mentioned before, this one... Oh man, cable length. So this plug fits fine, right? Let's try and reverse it for some reason, I don't know. Alright, so take this one out, put this one here. So this one doesn't fit fine, because it kind of hits the bottom on the screw there. So it's a little bit crooked, but not too much. So let's see if that still works. Because I really have to hate to change that. Oh yeah, that still works. Because I really like how these are now very compact little boards. Can we get some 10 gigabit Ethernet through the cable to... Yo, I have lots of 10 gigabit cables here in my house, so... Wow, okay. Is there a limit? Should it be possible to use multiple modules parallel? Yeah. So this is made for one channel only. So one channel goes in, one channel goes out. And the idea, once I've got this all hashed out, etc., is that I'll also create a 2-channel sender and a 2-channel receiver and a 4-channel sender and a 4-channel receiver. So you have options, basically. And reasons for that is, at some point, I'll probably want to create a little, you know, hat for on the DIG quad or for on the ESP32 itself, like an AE+, but instead of having 3 screw terminals on there for 3 extra data channels, you get an Ethernet jack, which has 4 differential outputs. So then if you want differential on your DIG Uno or DIG quad, you just take off the ESP you already have, you buy the one with the differential outputs, you pop it on there, and then you just need a receiver board on the other side, and you got 4 signals that can travel the distance. Now, the reason I created the 1 channel first is, how often do you need 4 channels all the way over there at the same point? I think more often you're going to say, I want 3 channels locally, and I want to use one of the channels 60 meters away. I don't know. So then you just take one of the single channel senders and single channel receivers. And yeah, it uses an 8-pin cable, but that's just because Ethernet is so cheap and easy. Everyone can crimp it and it's easy to use. And then you transport that channel the distance. But I'm looking at making multiple versions of it. Okay, so Philip, currently this 1-channel board is made cheaply, I guess you could say. So it only does 5 volt and 12 volt in. The output board, however, will do 5 volt, 12 volt, and 24 volt, or even 48 volt. As you can see here, because we're running 24 volt strip, while the controller is running 5 volt, right? The 2-channel and the 4-channel boards, I have to do some different things with the power circuitry. So those will be 5 to 24 or even 48 volt. So that's one of the advantages the 2 and the 4-channel will have over the 1-channel. That if you're running 24 volt on your main controller, then your sender board can also run that, while the sender 1 can't. I think screw terminals make sense for single and dual channel receivers, so one can use single Ethernet sender and split receivers. Yeah, but how would you split it, CJ? Would you somehow strip down the cable at the 40 meter length, take out that pair, and then continue the cable another 30 meters to another point? Or how do you see that? Any plans for daisy chaining them one off another? Well, you could. What's coming out of here, the receiver board, is just a normal data signal again. So if you'd hook it up this way, that'll work. You could use it in the garden where there's no strong... my cables are in the way. No strong Wi-Fi. Controller would be in the house and could send signals to multiple strips in a gazebo or something. Yeah, oh yeah, sure. If you had a 4-channel receiver, yeah, absolutely. A second Ethernet output connector. So you're basically saying a in-between board. Well, I guess I could design that as an extra. So then if you have a 2 or 4 data signals on there, you're stripping off one pair and using it locally, and then sending the other pair further along. You can now duplicate the signal with an RJ45 double port at the beginning and send the signal to another strip with a different voltage. You could put a hub on it. No, don't do that. Don't put this in a hub or a switch. Okay, so an in-between board might be interesting. So you could, for instance, send 2 or 4 channels over the Ethernet port, and then have an in-between board which strips off one of the channels. And then another Ethernet comes out, or an RJ45 comes out and runs another whatever distance. Huh. Yeah, I don't see the screw terminal part. Because I want this to be as plug and play as possible. Just playing with some effects. See if it makes a difference. Don't think so. Yeah, jumpers is an issue. Because any amount of resistance you put in between there is going to be problematic. I'd have to look into a way to do that. But basically, a board that only strips off one of the signals and then has the rest carry on. Yeah, exactly, Josh. So you'd maybe just have 8 dip switches, and then you can single out a pair which goes to the circuit, etc., and the others just continue. That could be interesting. Because there are other controllers like Culps and Falcons, and those all have differential ports, and they have receiver boards and things like that. But they have so many features and software features and things like that that it basically costs $30 for a receiver, and they don't even have sender boards in that sense because it's on their controllers. I don't want to create solutions that are that expensive because those already exist, right? And I don't want to create their very elaborate ecosystem with all kinds of software control and things like that. Because that already exists, and that works fine. I don't need to create that if it already exists and works fine. I want to create some boards which are cheap to use, but still provide a solution to use. And now, if you have a single strand that is on the other side of your house, like you're doing pixels, and you need it to go 60 meters, you just get a pair of these, and you're done. And it doesn't have to be that expensive. Oh no, James. Oh, well, yeah. You'd have to move the pairs. Whoa. That's gonna require an elaborate circuit. Because some simple dip switches cannot do that. No, I really meant the in-between board can split off a signal. So if you have a one-channel receiver on the end, that is always going to be on the first pair. So you set the in-between board to the second pair to split off, right? You can't really make it remap the pairs on the in-between board because that would be way too complex. No switches, just rotate the pairs on the output. I don't know what that means. Time for the new Coke. You're right there. Because this works great. So, it's time for the Rosalie. I have no idea how this tastes. So put a switch between it and have like 4 output, same signal. I'm confused. Go for the full 24 ports? No, no, no. This will only do 4 pairs, so you have 4 channels. Okay, here goes. Let's smell it. Ooh. That's an odd smell. Oh. Interesting. That's, I have no idea how to describe that smell. It's not bad. It really goes in your nose. Why not put the sender board on the dig instead of local connections and have 4 remotes? But yeah, mister, but then how many ports do you put on the dig? Do you put 1 port on there? Or 2? Or 4? And then how many channels does each port have? Oh, that's true, Solly. You could wire the plug differently, but that's all going into very much DIY solutions and not plug and play. But, you know, if you can do it, that'll certainly work. Secrets about the Quinled project. I wish. The Quinled project has grinded to a halt again, and I really need to get started with it. Again. Yeah, it's probably going to be a little bit shorter stream today. One of the things I'm going to try is see if the 5-volt strip also still works. There's no reason why it shouldn't. No, I don't think there's a secret today. There's a discussion of future products today. Thanks, Snailboy. So let's set the power supply to 5-volt first. There. Yeah, I know. Oh yeah, but there will be boards with transmitters built in. But I first want to make the ecosystem with external boards. And then once that is there, as I said, I'll probably create a little hat for on the ESP32, like the AE Plus board, but then with a 4-channel differential out. And then you can do that kind of stuff with it too. Okay, well that just works. Yeah, no problem. Test sender side on 12 volt. Well, I already did that test earlier, and that works fine. It doesn't work on 24 volt, however, because then it overheats. But the receiver side is no problem up to 48 volt, or it should be. And that's basically what's most important, right? So, a dig to go with USB PD 5 and 12 volt. I am working on that on the sidelines a little bit, but the usefulness of that is going to be very limited, because 5 volt LEDs are much more efficient than 12 volt LEDs, and thus moving to 12 volt isn't going to gain you that much. In regards to pixels, you could actually run less pixels on 12 volt than on 5 volt. And in regards to LED strip, if you have the per 3 addressable, you have 36 watts available instead of 15 watts. So that'll help a little bit, but not as much as you think. If you have a transmitters in your setup, the next PSU is a long way away. So 12 volt standard on a transmitter is pretty normal, I think. No. It doesn't matter if you put 5 volt or 12 volt on a transmitter. That doesn't change the signal. And the receiver board has its own power supply, right? So this one can be 5 volt or 12 volt, the sender. And then independently of that, the receiver can be 5 volt, 12 volt, 24 volt, or 48 volt. Doesn't matter. It would be nice if the differential had reused the onboard pins for the output so you could... Yeah. No, it would... with a double stack. No. It would use the same pins as the AE+. Most boring stream ever. It all just works. Yeah, I'm okay with that. It's going through this giant box of cable here. I mean, you saw me crimp the connectors on there. There's no foolery here. And yeah, that seems to be working fine. Have you made any progress on the constant current boards? I seem not able to find a chip which will give me constant current without PWM. So as long as I can't find that, I'm not really that interested in making a board that way. I might at some point, but currently that's on hold. I mean that indeed. 12 volt on sender, so no need 24 volt there. The receiver is a long way... Yeah, exactly. So that's why sender and receiver voltage is fully independent. And you can use whatever on the receiver side. And that's most important. Yeah, exactly, Emil. Yeah. So 5 volt and 12 volt compatibility on this side is okay. Although I do think I'll make the 2-channel and 4-channel boards slightly different. So that those will do 5 to 24 or 48 volts input and output. But yeah. Let's see if we dropped any frames today. 0 drop frames. Hallelujah. These are like the J boards I have. Okay. What's a J board? Oh, these will be available at Dr. Z's. These are currently just prototypes, although they seem to work quite well. I want to do a little bit more refinement on them. For instance, I'm not 100% sold yet if I want to do the power in like this. I did that to keep the board profile as sleek as possible, and then you still have these 2 screw holes here, so you can screw it down with M3. The idea was that you could route the power like so. So this would be the incoming side and this would be the outgoing side, basically. But having wire ferrules on there, of course, that doesn't work that great. Still, I think it's not bad having the power wires like this. And this was also to verify. This is a 330 UF cap, I believe. Yeah, which is a pretty high one. But because it's sandwiched in between the terminal and the fuse, it doesn't stand out. It's not higher than those, so fuse is the highest. This will do 5 amp or 10 amp fuses, that's fine. Yeah. A 48 volt compatible quad. Maybe in the future. Who knows? Emil? Yeah, but you know, it's partly it's about design for current stuff and for future stuff. But we'll see. Wouldn't it be possible to power the receiver from the sender over PoE and power the LED separately? Well, maybe in theory, probably not for 250 meters, because if you're sending 5 volt or 12 volt over 250 meters, you might get some voltage drop there. But then what use is it? Because you have to power the LEDs anyway, so you're going to have a power supply there. So then why run power over the cables if you have a power supply there anyway? Can you explain the use to me for that? Yeah, we first need 48 volt strip. For analog, it made sense. I have 48 volt analog strips. But for digital, it's a nice to have. It's not a need to have. Yeah, so what do you guys think about the issue with this screw here? If you look at it straight, you can see it's in slightly crooked, but it's still making a good contact and it's fine and it's not shorting on anything or whatever. But is that a problem? I'm inclined to think not, because I can just take it out and put it in, right? It's also very hot pluggable, see? It just stops, it freezes, because it doesn't get a data connection anymore. And then once you plug it in, it's back. Will it not break over time? No, it's not pinched that hard. It's just a very slight pinch. Yeah, there are 48 volt pixels. But then again, still, the receiver board will be 48 volt compatible. So then does it matter that the other side is only 512 volts? Maybe less. But as I said, if I can make it 48 volt compatible, I will. So yeah, no real secrets today. I've been heavily building and designing and doing stuff. That's also why there have been no videos and only live streams, because I've been designing and building stuff. I have tested it with a few different cables I have here, and especially the ones with a big plastic thule around it. You have to wiggle it in there, but otherwise it works fine. Turn the connector 90 degrees. Yeah, I thought about that, but then the plug, the lip would be on the bottom. I especially got a variant where the lip is on the top, because then it makes it very easy to plug and unplug even while it's screwed down, right? Where's the meet and greet? Yeah, Camp Zone got cancelled, so that could cancel too. Maybe at some point. Countersink. Well, sure, yeah. But, you know, maybe you don't even need this leg, or you use a different screw, but yeah. When will boards be available to purchase? I don't know. Once I finish them and do more testing. A bugle style screw. I don't know what those are. The reason I use this screw is because it comes in the bag with these little feet. Even if you just... oh, wait. I was going to say, even if you just use some of those plastic feet, it's not going to be a problem. But it is, isn't it? Huh. If you use those plastic push-through feet, then it'd probably be an issue. because then it would stick up through the hole. But I don't know how far. I might need to think about that. That might be an issue in regards to screwing these down. I had thought about that, of having one of the ears on this side and then one of the ears on this side. Yeah, it would stick up way too proud. Yeah, exactly, Joe. That's my problem. So maybe I need to change the design of having an ear over here and an ear over here. Because then it's, you know, it's balanced on two sides. And it's no longer a problem in regards to... I have thought about a connector that you can basically plug it in from the top. But I generally don't like cabling things like that. So that's why I generally do it inline instead of top line. Oh, a punch down block. That would probably add a lot of cost. And make it much more error prone, right? So now people can just buy a prefab cable, plug that in, done. Behind the RJ45. Yeah, but then it could still be a problem on this side too, right? Because if you have one of those plastic clips that you push through it, it would still interfere with the cable. Now I think moving it to the side, so over here and over there, that's probably the best idea. And then if users don't want it, they can actually still snip it off the PCB and make it smaller. Yeah, but the problem is I wouldn't be including screws with this, right? People would use their own mounting methods. And this is just a screw that came with these feet. Turn connectors 90 so that all cable enter exit on the long side of the board. No, I don't think that's a good idea. Yeah, exactly, Emil. But if I put the ears on this side, so on this side and on that side, and you wanted to make it inline and didn't have to screw it down, you could just snip those off, because it's just FR4 material, and then you'd still have the sleek board, or you keep them and then you can mount them down. CJ, Digital Analog still requires a bit more scoping. No holes, just hot glue. Well, exactly, but then you can snip off the side ears and then you can hot glue it. So, Digital Analog still needs a bit more scoping and optimizing in regards to resistors. It's still some wonky stuff going on there, but it's almost there. And then I'll probably produce a batch of, I don't know, 250, and then see where that goes. Randy, that is an option, but that would make the boards longer. So, yeah. And that only fixes, wait. That only fixes it on this side. But on this side we have the exact same problem if we use the push-through pins. The pin would stick up and interfere with the cables coming in. So it would still be in the way. I thought this was a good idea, but it isn't. So we might need to do little wing rings like we did on the Dig Quad, for instance. Or the Analog Quad, sorry. I know there's angled everything, but I don't like angled. And Nigel, I agree that flat countersunk screws will work, but then you have to get special screws to mount this down. And that's again a hurdle, making the product harder to use. It's not a bad idea, just not the final idea. Exactly, but that's why I do prototypes. That's the whole reason I build prototypes and test them. And this was a nice idea in my head, and in practice, it also kind of works, but it limits your options of how you're able to use the board. And if they're on the side, I think that's going to be much less of a problem. And then if you don't need them, because you're not going to mount them down and you're just going to glue them or stick them or whatever somewhere, you can just snip them off, and then the board factor remains as small as possible. Yeah. Yeah, but then you need the 3D print, Emil. I get it. They're all okay solutions, but they're not universal solutions for people who don't have a lot of crap in their house like we do. Exactly, Jardo. But I think I'll do a prototype with them on the side, and then see how I like that. Because that would solve all the issues. To have this come in a case. Oh. Well, the analog boards will each have their own case. I haven't thought about cases for this one yet. I still want to make that epoxy display with all the failed prototypes. Well, I have lots of good prototypes too. You would include tabs for screws, but on the same side of the board. But that would create extra stress on them. I'm not sure that's a good idea. Sure, Emil, but then you could just snip off those ears, and then you can pot it in. Quinled is now a case designer with a side of boards. Well, actually, for these cases, I rely on AllNet a lot. And they've been really busy, but we're starting to get it moving again. So, any update on the pre-assembled analog boards? Yes. They're currently at a few testers. So they're putting the boards through their paces and finding bugs and issues or, usability problems. And once that is done, and we also finish the casework, to make custom cases for them, or at least cases. They're not going to be as custom as the Dig2Go. Then I can hopefully release them soon. But, it always takes time. It takes more time than you think. We don't have a lot of crap in our houses. We have interesting and complex lighting solutions. Yes. Problem solved. Pot everything with a side of hot glue. So, Quinled, I know this is a little bit off topic, but you previously mentioned that you were self-taught on PCB design. What courses would you recommend to someone who's wanting to get into PCB design also? Whoa, that's a good one. There's a lot of good resources out there, like Phil's Lab or Robert Fernack, I believe his name is, and Altium has a very good YouTube channel. They explain a lot of stuff. And basically just YouTube tutorials on how to design things, how to design a buck converter, how to design in regards to ground and where it should be, and how to design your traces, and how to do impedance matching, and all that kind of stuff. They're very individual topics, and you don't need to need everything from the get-go. How are bypass capacitors used, and how do you know how many to use, and things like that. And then a large part of it is just doing prototypes, doing lots and lots of prototypes, and analyzing those prototypes. Don't just stick it in, like this, and say, "Ha, it works." Well, there's a large difference between it works or it works correctly. And so get a good multimeter, get a bench power supply, get a scope. The scope is invaluable to actually analyze the signals you're sending out and then verify if those are like they should be. So that's the hardest thing of testing is what should it be and what am I seeing? And those two should line up. And if you're seeing something different than what you think it should be, well, either of those is wrong. Even though it's working, I mean, it could be working, but it could still be wrong, basically. And then maybe it's working because of tolerance or because you get lucky, you know. And then through all that testing, you really learn a lot. Because then you can apply everything you learned from that testing and the data signals and why isn't it the way I thought it was to the next prototype or board, etc., and keep going like that. So that's really what I'd recommend. Start small, build maybe an ESP32 board or a buck converter, and don't build a project and a buck converter on it. Build a buck converter board. Power in, power out. Hook it up to your scope, hook it up to your multimeter and your bench power supply, and start testing and see what you need to do different. Change those things, make a new prototype, and then see what the difference is, and that's how you actually start understanding what you're doing. Because you can only start understanding what you're doing with experience, in my opinion. You can do as much theory as you want, but that won't really help you understand. It'll just teach you what to do, but not why you need to do that. But that's my method. I really like to understand how things work, not just that they work. And that's why I verify with lots of tools and things like that. I hope that kind of answers your question there, Iman. Tony Jackson just arrived. We pushed a LED data signal through 250 meter of cable. That's what we did today. Will WLED data line support 80 feet of the density, high density? You mean the 720 LEDs per meter addressable neon strip there, Mike? Well, 16 feet uses 100 zones. Don't go above 600 zones on one data channel. Do the math. Good fume extractor, yes, and soldering equipment, things like that. Make it like a dig-to-go box. I'm not sure which one we're talking about, but these, no, because that would add like $2 or $3 per board on cost. And well, that would raise prices a lot. For a set, you would pay $6 extra to have cases on them. And then a lot of people aren't even going to use the cases, right? Or you can 3D print something, or get a project box, or have it, you know, somewhere other way around, need a soap box. So I'm often a bit torn in if something needs a case or not. And in this case, I don't think a case would add that much value. So, especially if you can just use these little feet and it's off the ground, and you know that's already good. You can also use some standoffs or whatever. There's just M3, or get any other box, or even wrap it in tape. I don't care. Right? You can heat shrink it in. No, they haven't wrecked their dig to go because of removing the case. Generally, they don't remove the case. But I have had some orders for versions without a case. But what is the connector that goes into the dig to go? That is a JST XH, I think, at 2.5 millimeter. EEV block. Yeah, EEV block is good too. Hang it on the receiver board or available separate would be nice. The sending board would be next to the decoder or something. So less useful then. Sure, maybe. Yes, Savag, I'm thinking about making a 2-channel and a 4-channel board too. They'll have slightly different features, because those will also include power distribution and higher voltage support and things like that. But yeah, there's, should be multiple solutions for different use cases, I think. Right, we're about wrapping this up. Let's give it another 3 minutes, and then my Coke is done, and then we're done. It's still running. It's still running through that 250 meters of cable. I mean, that is pretty good. Right? Colors 1 and 2. Oh no, that's background. I don't want background. Whatever. Yeah, it works. Emil can finally sleep on time tonight. Off to bed. It's been a very nice stream. Thank you. Thanks for being here, Mr. Blue. Wait! What's going on, Philip? Only 2-hour stream? Seems so. You get like at least an hour off from duty. Soon you'll be able to go as long as you like when we see that new superconductor. What? Philip is like all disappointed. Everything works. Nothing blew up. Short stream. Worst day ever. Final thoughts about the new Coke. Yeah, I can't really pin down the taste. There's like cinnamon in there, I think. Let me see. Yeah, it doesn't say. It says Coke flavors. It's different. I'd buy it. I'd buy it again. Not like as my main drink all the time, but as a special drink. Oh, right. Okay. I don't know about those superconductors. I read a little bit about it, but... Rose kind infused flavor. I don't actually know what a rose would taste like, but it's pretty good. I like it. But, for sometimes. You want your money back? Well, I could insert an ad. YouTube tries to force me to insert ads the whole time. But, Similar to the smell of rose. No, this smells and tastes very different. Okay, guys. I'm going to call it for today. Thanks for being here and thanks for testing with me. We had another great success. It's always nice to have sometimes. We'll blow up some other stuff. We'll blow up some stuff another time. Okay. Thanks. Bye-bye.